Selective laser sintering is arguably the most production-ready 3D printing or additive manufacturing process for polymer parts. Selective laser sintering is also the most capable polymer additive manufacturing process for precision, complexity, accurate fine details. I am at Lifestyle Additive Manufacturing, a specialist in selective laser sintering. And part of what Lifestyle Additive does is guide manufacturers and product developers through how to realize the full promise of what selective laser sintering, SLS, can do. There is an SLS mindset, and in a series of videos, we're gonna talk about that in very practical ways. And I am joined by Nate Stevens, who is Director of Operations for Lifestyle Additive. Thank you for joining me.
I think you're joining me. This is my place.
Accurate. I'm the guest here. We're gonna do a series of videos, and in other episodes, we're gonna look at specific SLS promises. How do you design for strength? How do you design for precision? How do you design for cost savings? But in this one, we're just gonna go kind of broad and general. SLS, what can it do? What's it good for? Let's talk about that. So tee it up in very basic terms. Selective laser sintering, Nate, how does it work? And what really matters about SLS from a design perspective?
Starting with how does it work? Most additive manufacturing processes go layer by layer and slice the part up into really thin slices, and we build layer by layer to realize a three-dimensional part. SLS works the same way, but it uses a powder bed of a polymer powder and a laser to selectively sinter each layer where you want it. And so what that does from a large-scale production process is it allows us to have no supports, allows us to have solid infill on the parts, so we get stronger parts, more precise parts, and more parts in a build than you do with most additive manufacturing processes.
What materials are common for SLS? And how should we think about those materials in SLS versus maybe the same materials in molding?
Most of the materials in SLS are fairly typical thermoplastics. The most common is this nylon 12. There's also nylon 11, which is a little more flexible. We also have a flexible TPU that's more of elasto polymer, I think that's what they call it. And then various, versions of the nylon with different additives to give it different mechanical properties. It's a very versatile material. It's flexible if you design it right. It's flexible where you want it to be. It's rigid where you want it to be. It can go through some thermal cycling. It can resist UV and other radiation types. And so it's a pretty versatile material for a lot of different applications.
What are the clues that suggest to you want to steer them toward SLS as opposed to machining or molding?
The biggest clue for me is complexity. Is this a part that has lots of different features at all sorts of different angles that would benefit not having supports? It's much easier to 3D print this part because of its geometry and the texture and the internal features. SLS becomes the best solution for it because you can realize all of these features without having to really optimize or compromise on which orientation is going to get the most strength or the most material or the most support. You really can just print whatever you want.
And so for a part like this, you could get there through molding or machining, but it would be an assembly instead of a single piece.
Correct.
One of the design freedoms is assembly consolidation. What are some of the other geometries you look for?
Anywhere I see a lot of bolts and screws, that's an indicator for me that those two parts are going to be stuck together for a long time. Is there a way that we can combine those? There were a lot of plates and some springs that needed to be bolted to those plates, and then the plates had to be bolted together. SLS gave us the option to eliminate half of those parts and combine them into one part that performed all the same functions but was much, much cheaper to both build and assemble and cut down on overall labor costs.
How often are you designing for prototyping? How often are you designing for production? Or when are you doing both at the same time?
For me, it's always both. I'm always thinking about, okay, how do we make this long-term?
SLS is the additive process that really wants to scale up in quantity. Why is that?
So there's two main reasons for that. The first is material properties. You can get very consistent and repeatable material properties. And the other reason is just the sheer number of parts that you can pack in a single print volume. You can utilize the entire three-dimensional space inside the printer and pack as many parts as possible. You're not just thinking about how does the part look when it's done, but how can you fit as many as possible and still have it function the way that you want it to function.
Some polymer parts are headed for molding, and SLS has a role prototyping and developing a part that might be headed for molding. So how does that scenario change or affect how you think about part design?
SLS gives you the opportunity to realize production-ready parts without the incurred cost of injection molding. And so it allows you to iterate on your designs, release a product, get some feedback, make those changes. We just print the new file to get the best product before you spend all that money on molds.
SLS can give you a prototype that is very, very close, if not functionally identical to what the molded part will be.
Yeah, SLS is the only 3D printing process that I've found that has the fewest limitations. It gives you production-ready parts so that even in the prototyping phase, you can properly evaluate whether your parts are going to work or not.
What is a practical or possible batch size for an SLS production run? And then also, what is a typical workable batch size when you're still in the prototyping phase and you're still iterating?
On the prototype side, can we nest your parts with other parts? Small itty bitty parts, we find a way to print them. For production, something like this, I can fit about 65 of these in a build frame, 200 of these, 500 of these. It really is kind of variable and dependent on the part geometry. I try to work with the customer. How can we optimize this for production, maximize our production amounts and minimize our post-production?
How would you summarize the SLS mindset, or how would you begin to summarize?
I described it as kind of out of the box thinking, sky's the limit. Once you see what your parts look like in SLS, it just clicks and everything, you start seeing everything in terms of printing with SLS.
It's almost a matter of unthinking.
Yeah.
Because you can get different functionalities and very different features all in one design.
When you kind of let go of those questions and just start asking different questions like, how can I combine these two parts? How can I incorporate a living hinge here? It opens up a lot more opportunities while you're designing and really gives you a lot more freedom to build what you want.
This episode's part of a collection on the SLS Mindset, how to design for selective laser sintering. Check out other videos in this series.